So still factoring by decomposition, these are different in that there are two variables now. Instead of going just x squared, x, and then constant, these have a term with x squared, a term with x and y, and then a term with y squared. And so what does that change about our procedure? Almost nothing. We still look for common factors, and there are none here. Then we still look for the middle coefficient, which in this case is -5, and the first times last coefficients, which would be 2 times 2 is 4. So we need a couple of numbers which add up to -5 and multiply to 4. It's a pretty short list of candidates. It can't be 2 and 2. Those won't add up to 5 no matter what you do with the signs. But if you use -4 and -1, that'll do what we need. Those add up to -5, and when you multiply them, you get 4. So we rewrite this expression. The 2x squared does not change. On the end, the 2y squared does not change. In the middle, we have -4xy minus 1xy. You don't need to write that 1 at all, but I'm going to, just to make sure it's clear. And now we look for common factors, factor by grouping, as we've done with all the other examples. Common factor here, we can take out a 2 and we can take out an x. Leaves us with x minus 2y. For the next pair, our first term is negative, so we'll factor out a minus for sure. 1 and 2, there's nothing we can do with that. We can factor out a y, and that leaves you with minus factors out, the y factors out, we're left with x. 2 divided by -1 makes -2. Y squared divided by y leaves us just y. So our common factor is x minus 2y. Pull that out. And what's left behind afterwards is 2x minus y. So, yeah, these look worse. They've got the extra variable, but you notice it doesn't really change anything about our procedure. It's just a little extra writing that we have to do when we're doing the factoring by grouping. The way that you handle your coefficients and the numbers that you select are exactly the same as we were doing before. So, not a big deal. Let's try it again. No common factors. Middle coefficient is -3. First times last is 2 times -35 is -70. So how many ways are there to make 70? The obvious one. 2 goes into 70 35 times. 3 does not go into 70. 4 doesn't go into 70. 5 goes into 70 14 times. 6 doesn't go. 7 goes into 70 10 times. 8 doesn't go, 9 doesn't go, 10 is already on our list, so that means you can stop looking. You've got them all. So, which of these pairs of numbers could add up to -3 with the signs suitably tweaked? 1 and 70 can't do it. 2 and 35 can't do it. That can give us either 9 or 19. That's not it. Here we go. It could be 7 and -10. 7 and -10 can add up to -3, and they multiply to -70. So here's our rewrite. 2n squared. On the other end, minus 35m squared. And in the middle, instead of minus 3nm, we get plus 7nm minus 10nm. You notice how these are out of alphabetical order? That's not great. I'm not thrilled about that, but I'll grit my teeth and live with it for now. When we get to our finished answer, I might decide to polish that up and flip those letters around, but for now I'll just pretend I didn't notice. Factor by grouping is the next part of the drill. Here I can take out an n, and that's actually it. That leaves us with 2n plus 7m. From here, they're both negative, so I definitely want to factor out a negative number. I can take out 5. They both contain an m. There's no n in this term, so I can't factor an n out. What does that leave us with? Minus 10 divided by minus 5 is 2. m factors out, so we're just left with the n, and here minus 35 divided by minus 5 is plus 7. M squared divided by m is m. You might be sitting here saying, look, you know it's going to be 2n plus 7m, why don't you just get on with it? I try to force myself to play dumb and not take advantage of this when I'm doing the factoring. Really calculate these numbers, and then when you get to the end, if you've gotten this value twice, then okay, you've earned it now. You know that these are correct because you've done it twice. The second one acts as a double check. If you mess this first one up, and then you assume it's going to happen again and just write it again, now you've just set a trap for yourself and walked right into it. So please, even though you know this pattern is supposed to happen, don't force it to happen. Do these calculations for real, get an honest result, and then when you check it, see if you get the common factor. The common factor, speaking of which, is 2n plus 7m. And with that pulled out, we're left with n minus 5m. You could leave it like this. We could switch the order on both of these if we wanted to have the m before the n. It doesn't produce a beautiful result, and it takes a significant amount of work, so I'm going to do it, but I'll box this first to show that this is not a terrible answer. Your alternative is flip this first term around, 7m plus 2n. You flip this term around, now something bad happens here. You get minus 5m plus n. And this leading coefficient being negative is not a good thing, so the way you fix that, is you factor out a negative 1. And now you've got the 7m plus 2n is unchanged. And here, negative 5 divided by negative 1 gives us 5m. N divided by negative 1 gives us negative n. So here it is in alphabetical order. You can see why you might not choose to do this, because having the negative 1 out front is not all that nice. But if alphabetical order is important to you, this is what it will look like. If you don't care about that so much and you want an easier to read answer, then here you go. Here it is with the n's before the m's.